All right. So just kind of starting over since I'm recording now. So we have exponential form, a raised to the power of y is equal to x. That's equivalent to this log y is equal to log base a of x. Notice that as far as my log is concerned, this thing is read as y is equal to the log base a of x, where a is the base of your log and x is called your argument. So if you hear me say things like the argument of your log, I'm simply referring to x. Before we actually go any further, I just want to take a look at some things visually. Notice that when you rewrite an exponential function as a log, the base of your exponent is also the base of your log. So notice in these examples, we have exponential form in one column, we have log form in the other column. Notice that from this first exponential form, my base is 2. The base for my log is also 2 when I rewrite it in log form. Excuse me. Take a look at the second example. The base for my exponent is 1/2. The base of the log is also 1/2 when we rewrite it. We take a look at the next example. The base is 5. The base of my log is also 5. And then for this last example, my base is 3/4. That's also the base from my log. Notice that your power, right, which in this case is y, that's what your log should be set equal to. So just looking at some examples, notice that my exponent is 3, and then notice that my log equation is set equal to 3. For the second example, -4 is my power. Notice when we convert that to a log, it's equal to that power, -4. For the next example, my exponent is 1. Notice that our log is set equal to 1. And then lastly, the power is 0. And just notice that when we convert to the log, it's actually set equal to that power, which is 0. And lastly, we have x, which is the argument. So notice we have a raised to the power of y is equal to x. Notice that when we convert that to log form, that's actually the argument of our log. So looking at these examples, notice that the exponential form, we have 2 to the third power is equal to 8. Notice that 8 serves as the argument for my log. Notice on the second example, we have this exponential function set equal to 16. 16 is the argument of the log once we convert it over. Looking at the next example, notice that this is set equal to 5. And just notice that 5 is the argument of the log. And then lastly, we have the exponential is equal to 1. So notice that 1 serves as the argument once we convert it. So here again, when we're asked to solve a logarithmic equation, we must change the log equation to an exponential, and then we'll solve the exponential. So here's a quick look at an example. We're asked to solve log base 4 of x is equal to 3/2. So what we're going to do is convert this log to an exponential, right? So when we convert log base 4 of x equal to 3/2, remember that the base of your log is the base of your exponent. Notice that x, which is the argument, That's what our exponential should be equal to. And notice that 3/2 is our power. So when we convert log base 4 of x is equal to 3/2, we can write that as 4 raised to 3/2 power is equal to x. And if we calculate 4 to the 3/2 power, we would get 8. So solving this exponential gives us 8. Okay, before we go any further, I want to take a look at some homework problems. And in particular, we'll take a look at problem number 1. Okay, and I'll generate another example. So here we're asked to rewrite this exponential in log form. Okay, so I'm going to switch to our document camera. All right, and we have this problem as, so this is 5.3, number 1. 2 to the 6th power is equal to 64, and we're asked to write as a log. All right, so just remember our conversions. The base of our exponent is 2. So that means that the base of the log should be 2. So I'm going to write this as the log base 2. Remember that our argument is what our exponential is set equal to. So this is set equal to 64. So my argument for my log should be 64. And then notice that our exponent is 6. And 6 is what our log should be set equal to. So we can rewrite 2 to the 6th power equal to 64 as log base 2 of 64 is equal to 6. All right, so if we return to the homework problem, I'm going to put in as the log. I'm going to put in my base, I'm going to use this subscript. My base is 2. I'm going to use my forward key to take me out of the subscript area. I'm going to put in my argument, which is 64, and this should be set equal to 6. All right, so we've converted an exponential to a log. All right, I also want to take a look at problem number 7. And in problem number 7, we're given a log equation and we're asked to solve for x. So we're given log base 2 of 8 is, I'll generate another example. All right, so generating another example, we have log base 4 of 16 is equal to x. And we're asked to solve this equation, so we want to solve for x. Okay, so just writing this down, this is number 7, 5.3.7. We're given log base 4 of 16 is equal to x. And we're asked to solve. Right? So in solving, we must convert this log to an exponent. So when converting to an exponent, notice that the base of my log, which is 4, that should be the base of my exponent. This log is set equal to x. Therefore, x is my exponent. The argument of our log is 16. So we're going to set our exponential equal to 16. So now how do we solve it? Well, since this is in exponential form, I'm going to try to use the change of base. For 4 to the x, I have a base of 4. I'm going to bring that down. I want to rewrite 16 as a base 4. So 16 is 4 squared. Now, since we have the exact same base, we can drop the base, set our exponent equal, and solve. All right, so here we solve for x, and we have x is equal to 2. All right, so once we solve for x, we see that we should have 2. All right, I'm going to return to our PowerPoint slides. And here's just some further examples. For this example, we have x equal to the log base 8 of 4. So here again, we will rewrite this log as an exponential. So notice that the base of our log is 8. When we convert that to an exponential, notice the base of our exponent is 8. Since this log is equal to x, we're going to raise 8 to the power of x. And we're going to set that equal to 4 because 4 is the argument of our log. So next, the change of base was used. We can rewrite 8 as a base 2, so 8 is 2 to the 3rd power. We can rewrite 4 as a base 2, 2 to the 2nd power. Notice that our rules for exponents, when we raise a power to a higher power or another power, we multiply. So we can write 2 cubed to the power of x as 2 raised to the 3x power. We have like bases. We drop the base, set the exponent equal, and solve for x equal to 2/3. And the same thing is done for the second example. Log base x of 16 is equal to 4. So rewriting this as an exponential, right? The base of our log is 4. Therefore, the base of our exponent, the base of the log is x. Therefore, the base of our exponent is also x. We're going to raise x to the 4th power and set it equal to 16. The way that this problem is solved is we can raise both sides to the 1/4 power. Right? If I have x to the 1/4 raised to the 1/4, 4 times 1. If I were to take 16 and raise that to the 1/4 power, I would get 2. Since we have an even index, we must include the plus or minus. We won't run into any problems at all that actually uses plus or minus. Most of the problems we're going to look at are going to be pretty much straightforward as in this example. All right, now as far as the calculator is concerned, I'm going to go back to our document camera. And if you have a calculator, you may want to pull out. All right, and we're going to take a look at a couple of things. Hopefully you can make this out. I think it may be best for me to use the actual calculator on a computer. All right, so I'm going to bring up the calculator on the computer. All right, and just kind of looking at our calculator, there are actually two types of logs. There is this log log, and there's this ln, which is natural log. The log log is what is called a common log. Common logs have a base of 10. For example, here we have the log of 12. If I want to use my calculator, I'm going to turn that on. I'm simply going to put in the log and I'm going to put in 12. I get 1.079. Sometimes you may see log written in capital letters. Sometimes you may see log written in lowercase letters, but they're one and the same. As long as you don't see a base, the base is understood to be 10. I can evaluate the log of 0.1, so I can put in the log of 0.1 to get -1. I can also put in the log of 3/5. So since I do not see a base, it's an understood base 10. So the -0.22. There is another type of log called a natural log, and a natural log has an understood base e. But when we write out the log with a base e, we actually write it as ln, or natural log. Right, so you will very rarely see e written as a base. Instead, be written as a natural log. So common logs have a base 10 and natural logs have a base e. And we can use the calculator to evaluate. So here we're asked to evaluate the natural log of 8. I'm going to put ln of 8. Now, if I were to put in log of 8, notice that I get a completely different answer. Right, so if you're dealing with a common log, make sure you use the log. If you're dealing with the natural log, make sure you use this ln. And here again, ln can be lowercase or ln can be capital case, but they're one and the same. I can put in a natural log of 1, and I can put in the natural log of e raised to the 4th power. So that's a natural log, and e is located above the ln, so I'm going to hit second and the exponential e. I'm going to put in my power, which is 4. I'm going to close off the exponential e. I'm going to close off the natural log, and we have 4. All right, so next we have some what are called properties or identities. All right, so for this first property of logarithms, it says that the log of a, the log base a of 1 is equal to 0. Now, a can be any value. A can be 10, it can be 6. Just keep in mind that a has to be positive. It has to be greater than 0, and it cannot equal to 1. So if you were to write this as an exponential, the log base a of 1 equal to 0, the base of the log is a, therefore the base of your exponent is a. You would raise a to the 0 power, and you would set it equal to 1. And by the 0 exponent rule, anything to the 0 power is 1. The second property says the log base a of a raised to the power of k is equal to k. This is what's called an identity. If the base of your log, which is a, is the same as the base of your exponent, the value is the exponent. All right, so if this were log base a of a to the 6th power, then it would equal to 6. And then our third property, and it runs on the same concept, is a raised to the log base a of k, that's equal to k. So notice that the base of my log is, the base of my exponent is a. The base of my log is a. If the base of my exponent and the base of my log are the same, the value is the argument of the log, right, which is k. All right. I'm going to go back to our homework problems and we'll take a look at problem 10. And I'll generate another example. So here we have 7 raised to the power log base 7 of 2. Notice that the base of my exponent is 7. The base of my log is 7. So the value should equal to the argument of my log, which is 2. All right. You can actually put this in a calculator to get 2. Right. I can put in 7 and I can raise that. Well, actually, before we do that, there's another formula we have to talk about. Something called a change of base, which we'll talk about that shortly. And then we'll be able to put this into our calculator. All right, so next we have these additional properties of logs. And there's 3 rules. There's a product rule, a quotient rule, and a power rule. The product rule says log base a of x times y is equal to log base a of x plus log base a of y. So when you're dealing with a log, you can rewrite a product as a sum. The quotient rule says log base a of x divided by y is equal to log base a of x minus log base a of y, which means you can write a quotient as a difference. And then we have this power rule, which really doesn't seem to make any sense at all. It says that the log base a of x raised to the power of r is equal to r times the log base a of x. So just looking at this visually, it seems like this power of r was just simply moved into the front of our log. And these things should be equal. All right, so next I'll actually plug some numbers in and we will see why these properties work. All right, so I'm going to go back to our shared camera. And we're going to take a look at this first formula, which was the product rule. And it says that the log base A of x times y is equal to log base A of x plus log base A of y. And since this is a formula, I'm going to put it into a box. So now I'm actually going to substitute in some numbers. And I'm going to take the log of 8. And just to keep things simple, I'm going to use common log base 10. All right. So in my calculator, hopefully you can make this out. I'm going to put in the log of 8. And we get 0.903. Okay, so what this property says is if I can find two numbers that I can multiply to get 8, I can take the same two log of those numbers and add them. And so here's what I mean by that. I can take 8 and I can write that as 1 times 8. 1 times 8 is 8. Or I can write that as 2 times 4 because 2 times 4 is 8. That's going to allow me, as far as this log is concerned, to rewrite the log of 8. And I'll just take this first example. I can rewrite the log of 8 as the log of 1 plus the log of 8. Now, it may not make too much sense because the log of 1 plus the log of 8, if we think about addition, it would be assumed that this is the log of 9. Right? But I'm not actually working with a 1. I'm not actually working with the 8. I'm working with a log of 1 and a log of 8. Just to show that these two things are equal, I'm going to put in the log of 1 plus the log of 8. And notice I get the exact same result. I can also use a 2 and a 4. I can write the log base 8 as the log of 2 plus the log of 4. So let's verify that. So I'm going to put this in the calculator as the log of 2 plus the log of 4. And those I get the same number, 0.903. So the log of 2 plus the log of 4 is not the log of 6. Because that's not a 2, that's not a 4, that's a log 2, and that's a log 4. Right? And this is the product rule. Next, we will take a look at the quotient rule. And the quotient rule says that the log base A of x divided by y, that's equal to the log base A of x minus log base A of y. Right? So I'm going to use the same log of 8. All right, so what this formula says, if I can find two log numbers that will multiply and give me 8, I can write those out as a difference. So I could use 8 divided by 1, because 8 divided by 1 is 8. I could use 16 and a 2. I can use a 24 and a 3. And that'll keep on going. So I'm going to try a couple of these. I'm going to use the 8 and the 1. This quotient rule will allow me to rewrite the log of 8 as the log of 8 minus the log of 1. So I'm going to put that into the calculator. The log of 8 minus the log of 1. And I get the same value, 0.903. I'm going to use the second setup. I could rewrite the log of 8 as the log of 16 minus the log of 2. So I'm going to put that into the calculator. So I'm going to put in the log of 16 minus the log of 2. And I get that same value, 0.903. You could use 24 and 3 as well. You can write the log of 24 minus the log of 3. And notice we get the exact same value. So what I'm trying to show here is that these formulas do work. I'm just putting in some real numbers so we can physically see what's happening in these formulas. So we're going to look at power rule, and we're actually going to use these in a problem. So this is the power rule. And the power rule says that the log base A of x raised to the power of r is equal to r times the log base A of x. And this is called the power rule. All right, so I'm going to use that same 8 that we've been using. I'm going to write 8 as an exponent. I'm going to write 8 as the log of 2 raised to the third power. Right? 2 to the third power is 8. I'm just writing 8 as an exponent. So now what this formula says is that I can take my power, I can shift it in front of my log, and I should have the same result. So the log of 2 to the third power can be written as 3 times the log of 2. So if I put that in my calculator, I'm going to put it in as 3 times the log of 2. And notice I get that same result, 0.903. So whenever you have your log written out as power, you can simply take this power, treat it as a multiplier, and you would have your result. All right, let's take a look at an example. All right, we'll take a look at problem number 18. All right, so in problem 18, we're asked to use the properties to rewrite the expression. We're given the log base 2 of 3y divided by z. Okay, so I'm going to go back to our document camera. So this is 5.3, number 18. Log base 2 of 3y divided by z. So just a couple of quick things before we actually rewrite this out. Notice that from our formulas, I can treat any product as a sum. So I have 3 times y, so I can rewrite this as the log base 2 of 3 plus the log base 2 of y. Anything that's in your denominator has to be written out as a difference. So here's what I mean. I can write this out as the log base 2 of 3 plus the log base 2 of y. Right, I'm rewriting this product as a sum. Next, I'm going to write out this division, or everything that's in the denominator, as a difference. So since this z is in the denominator, I'm going to write this out as minus log base 2 of z. And this should be our final result. So if we go back to our homework problem, this is the log base 2 of 3 plus the log base 2 of y minus the log base 2 of z. So I believe C should be our correct response. All right, and then there's one more I want to take a look at, number 19. All right, so just to show how I got this answer. And all the problems that we've seen up to this point, you will likely see those on the test. Okay. Probably won't see one like number 19 on the test, but just for clarity, I want to go through this problem. All right, just to show how this answer is developed. I'm going to go back to our document camera. And this is 5.3, number 19. We have log base 7 of 7 times the square root of 13 divided by 2t. Now, sometimes you may see the argument in a set of parentheses. Sometimes you may not see it in a set of parentheses. All right, but here the base of our log is 7, and then our argument is 7 times the square root of 13 divided by 2t. Right? So previously, right, in that previous problem, we were able to rewrite all products as sums. So notice I do have a product in the denominator, but in a denominator, I would write out everything in the denominator as a difference. So just notice how this problem is going to play out. So for our numerator, I'm going to rewrite the numerator as the log base 7 of 7. Plus the log base 7 for the square root of 13. Right, so I have taken everything in the numerator and I'm writing it out as a sum. I want to take everything in the denominator and write it out as a difference. So since this 2 is in the denominator, I'm going to write that out as a difference. So this should be minus log base 7 of 2. T is in the denominator as well, so I'm going to write that out as a difference. So this is minus log base 7 of t. I want to simplify these things down just a little bit more. Notice for my first term, log base 7 of 7, which is sort of like that identity. Notice that the base of my log is 7. The base of my exponent is also 7. So this 7 can be written out as 7 to the first power. So this first term should actually equal to 1. Okay, and that's by the identity property. For my second term, I want to rewrite this square root as the 1/2 power. I'm going to write this out as a log base 7 for 13 raised to the 1/2 power. I'm going to bring everything else down. Minus log base 7 of 2 minus log base 7 of t. Lastly, I want to use the power rule. Right? The power rule says I can take this power and I can treat it as a multiplier. So for my final result, I should have 1 plus 1/2 times the log base 7 of 13 minus log base 7 of 2 minus log base 7 of t. All right, and if we were to just compare that with an answer choice, right, just notice the result, 1 plus 1/2. So that square root was written as a 1/2 power, and we use the power rule. 1/2 log base 17. Next, we've written everything in the denominator as a difference. So we have minus log base 7 of 2 minus log base 7 of t. All right, so for today, we're only going to go through one section just because of the material. When we meet again on Thursday, we'll take a look at section 5.4.